Hey everybody, Mr. Sands coming at you in yet another screencast for Algebra. And in this video I'm going to be walking through the third method of solving systems of equations. We have kind of already gone over graphing. That's an easy, pretty simple way to think about solving a system of equations. You got one equation, you graph it. You get the other equation, you graph it. If they meet and intersect once, there's one solution at that point of intersection. If they're parallel and they don't meet at all, there's no solution, empty set. If the lines are literally right on top of each other, they are exactly the same line, then that means there are infinite points of intersection. So this is on the Jamboard. I just kind of basically covered this right now. We've already gone over it, but it is here if you need more information. Also, we've talked about method number 2, substitution. This is when you are going to solve one equation for one variable, and then you take what you got, you plug it into the other one, and then you solve that one. So in this example, I'm taking this one, x minus 2y, I solve x in terms of y, and then I plug it in here, so now instead of x, I'm writing another y, so I've got all y's, I can get y equal to a number, and then I plug y in, and I get a number for x. And remember, all of these all of the answers for these solving systems of equations are going to be in the form of an ordered pair, or an infinite answer, or an empty set. So remember to write your solutions as an ordered pair. Third method, elimination. We covered a little bit in class today. I made a little mistake because I wrote one of the problems down incorrectly, but I fixed that now. I'm going to walk you through how to go through a little more complex problem. This was the easy one we did in class. How you do it, how you set it up. For the easier problems, they're going to be kind of set up already for you, because you see here, I want you to think in columns. That you've got a column right here for your x terms, you've got a column right here for your y terms, and you've got a column right here for whatever numbers are left on the other side of the equal sign. This one works out really well, because if you can think of setting them up into columns, you're just going to add or subtract right down the line. So x plus x is 2x, y minus y is no y's, they cross out, that's cool, that's what we want. 1 plus 5 is 6. 2x equals 6, we can divide both by 2, we get x equals to 3. Remember, we got to plug it in and solve for y though, so x equals 3, I can plug it into this one, I can get an answer, I can plug it into this one and get an answer. Either way, I'm going to get the same answer, I should get the same answer. In this case, y equals negative 2. So my solution is the ordered pair, the point, 3, comma, negative 2. So 3 over and then negative 2 down. It's that point, that's where those two lines are intersecting. We did this one in class, where we have 4x plus y equals negative 9 and 4x plus 2y equals negative 10. And so what I did for that one was took negative 1, multiplied it by the 4x here, took negative 1, multiplied it by the 2y, took negative 1, multiplied by the negative 10. So when I do that, I get a negative 4x, a negative 2y, and a positive 10. Then I think of my columns, right? Flashy. Column here. Column here, column here, okay? So my x's cross out. 4 minus 4 is 0, that's why there's nothing there. Positive 1 minus 2, that's going to be a negative y. And then negative 9 and 10, that's a positive 1. That's real easy. I can flip both of these and get a positive y equals negative 1. And then I got to plug it back in, remember, and get my other variable. So if y is negative 1, that means x is negative 2. So my ordered pair solution is negative 2, negative 1. So remember also, piece of my solution, single circle, piece of my solution, single circle, final solution. Make it real easy to determine what your final answer is. Vigorously circle it. This was what I made a mistake on. I forgot to include the negative here. Even though I was going through the process as I needed, it started to get a little ugly over here with some really unmanageable fractions. This is the correct answer that we should be getting. So let's check our work and see if we come at come to the answer of negative 2, 1. And I'm going to leave the slide on here as a way to say, remember my mistake, but heed my warning. Make sure you copy the problem down correctly, as I have done so here. So let's go ahead and do this problem now. So what I notice is that the x's are stacked, but they're not going to cross each other out. The y's are stacked, but they're not going to cross each other out. And the numbers are stacked. I don't really care about crossing the numbers out. I want to figure out what I need to do to get one variable to eliminate. Well, what I was saying is that if I multiply everything in this top term by 2, 2 times 3x, that's going to be 6x. 2 times negative 4y, that's going to be negative 8y. And 2 times negative 10, that's going to be negative 20. The next one stays the same. I'm not doing anything to it because I'll show you why. This is still a 5x. This is still a positive 8y. And this is still a negative 2. Now I've got columns, right? I got a column here. I got a column here. I got a column here. That's what I want. So 6 plus 5, that's going to be 11 x's all day. These are going to cross out because this is a negative 8, this is a positive 8. That's what I want. Good. Negative 20 and negative 2 more. That's going to be negative 22. This is already looking a lot easier than what I had because 11x and 18, those numbers really don't seem too much related with each other. But already, 11x, negative 22, I know that 11 times 2 is going to be 22, whether it's positive, negative. I at least see there's somewhat of a relation with these numbers, which makes me feel good, makes me feel like I'm going in the right direction. One negative sign can really change things. That's why it's important to copy the problem down correctly. Say that over and over. I'm just going to rewrite it without the space there. And then what I need to do is I need to get x all by itself. So let's change my color up. Let's do red. I'm going to divide this by 11, and then I also have to divide this by 11. So these cross out. That means I'm left with an x here. Negative 22 divided by 11, that is going to be negative 2 all day. One circle, because that's a piece of my answer. So if x equals negative 2, x equals negative 2, I'm going to pick a problem and plug it in to figure out what y is going to be. Well, let's see. I'm going to plug it into the original equation here because this is 3 times negative 2. That's less math. 3 is a smaller number than 5. That's the only reason why I'm doing it. I'm going to get the same answer in both of them. It doesn't matter which one I do if I'm doing the math correctly. So let's start out. 3x, make sure I copy it down right, 3x minus 4y, using the original, equals negative 10. It's a color we haven't used yet. We'll use green. So x is negative 2. So x is now a negative 2. So now this means we've got 3 times negative 2 minus 4y equals negative 10. Now we only have one variable. That's great. So I want to get y equal to a number. Well, 3 times negative 2, that's pretty simple. That's negative 6. And the negative 4y comes along for the ride, as does the negative 10 right here. I think can we see the yellow? Yeah, we can see the yellow. Add 6 there, and then that means I got to add 6 there. So these will cross out. Negative 4y is still there. Nothing has changed. Negative 10, positive 6. Well, if I'm thinking on my number line, negative 10 is going to be over here, and I add 6, I'm still going to be on the negative side. That's going to be a negative 4 all day. Now, this looks pretty good. This looks like it's going to work out nicely because I can divide. Let's go back to blue. Use it again. If I divide this side by negative 4, I'm also going to divide this side by negative 4. These cross out, which is what I want. Y is equal negative 4 divided by itself. Anything divided by itself is always going to be 1 because it's a negative and it's a negative. So that's going to make it a positive also. So y equals positive 1. So I believe that's what we said. And if I get in the habit of writing my final answer in green and circling it vigorously, my final solution will be negative 2, comma 1, the ordered pair. That is my final answer. And I wrote it down here, negative 2, 1. That's what we should have got. And that's what we did get. So that is one way of looking at solving systems of equations by using the elimination method. Hopefully, me working through the problem correctly and not making any mistakes has showed you another way to kind of go about it. Sometimes these problems are going to stack up like here. What was our first example? These stack up really easily. Sometimes it might be stacked up a little more difficult, so you got to change something. And then sometimes you might have to change not only all the terms in one equation, sometimes you might have to multiply all of the terms in this equation by one number, and you might have to multiply all of the terms in the other equation by another number. That would be maybe the most complicated. So maybe we'll do something like that next time we meet. But for right now, I hope that this video has helped show you how to work through a problem and maybe answered some questions and helped with some clarification. Tune in next time. I'll show you how to do some more math. Peace out. Later.